Let's look at call stacks, which are also known as activation records. This is a data structure that stores information doing program execution. So a stack is kind of like an array. Right now, we're looking at this from vertical standpoint. So these are actually slots, where the very first slot stores I equals 5, second slot stores j equals 2. Call stacks in general have last in, first out property, which means the very last item that goes into a call stack is the first one out. So if you look at this being the very first item that goes in, K being the very last item, if we were to pop a record out of this call stack, K would have been the first one to go out. In the next couple of frames, we're going to look at an example call stack when a max method is called. You'll see these values going in and out of call stacks until the program is complete, in which case the stack becomes empty and your application is done. An activation record is essential for supporting the execution of methods in most programming languages, especially those that allow recursions and function calling other functions. Activation record is created and pushed onto the call stack each time a function is called and is popped off of the stack when the function returns. This is the reason why when function returns, the stack is empty. Let's look at how a call stack works. You have a main function. This main function has a couple of initializations, creating integers I and j plus k, and there is a method invocation. This method is a static, which is basically a function that has two parameters, comparing to see which one is the biggest, and returns the max of the two. So since your main is the point of entry for a program, the very first element I is stored inside an activation frame or a call stack. This is when main method is just invoked. Let's look at the next frame. Now that we have j equals 2, remember a call stack is last in, first out. J is stored after I in this fashion, so our call stack actually grows vertically top. Let's look at the next frame. Now that we have k, remember k stores the return value of max methods. And since k does not have anything before the max is complete, we simply store this value k here, and the value is undefined. This is what happens when you just declare a variable. Upon declaring k, we have this assignment, which then invokes the L value, which is your method, defined here. Let's look at the next frame. Now we are at a function invocation. Both your I and j's are the arguments passing into this max function as parameters number 1 and number 2, respectively. Notice that when the function is invoked, nothing needs to be stored. Technically, each function has a function pointer, or the memory address associated with that function, and that memory address is stored inside the call stack, but it is not illustrated here for the sake of simplicity. Let's look at what happens next. Now that your num1 and num2 would take the value of I and j, respectively, these parameters must be stored. These are what we call the local vars, local to your max function, which means num1 and num2 is not going to be known outside of this method. Therefore, as your flow of control continues, num2 bears a value of 2, num1 5, and they are pushed into the stack in that order. Num1 goes first, num2 goes second. So now you have a total of 5 variables, I, j, k, num1, and num2 in your call stack. Remember, your growth of stack is up this way. Let's look at the next frame. Now that your flow of control is inside this line, calling for integer results, notice that this result is only declared, so we push that key into your call stack with a undefined value. In Java, an integer variable has a default value of 0, but since we don't illustrate it here, we're just going to leave it empty. Let's look at the next flow of control. Next, we have conditional statement comparing num1 and num2. Let's clear this. There's nothing to be stored because we already have num1 and num2, as these 4 lines calls for evaluation, not storage. We know num1 is 5, num2 is 2, because of I and j values. So this line is evaluated, results equals num1. As soon as this statement is evaluated, result has a value of 5. due to this assignment. So we push that 5 into the result in the call stack. Let's clear this and move on to the next frame. Next up, your flow of control is about to return your results back. Notice this is a little tricky because now that we have results equals 5, and this result is about to be assigned into the value k as your function max returns. As soon as this returns result is evaluated, a couple things happens. Remember you have num1 and num2. These are local variables to max function, and both these variables will be out of scope, meaning they will get popped out of call stack as results exit. So this thing will be popped, and num2 and 1 will be popped one at a time as your function exits. And because the value returned from max, it will be assigned into the value of k equals 5. Now your entire stack remains with these three values. Call stack is last in, first out. So as your flow of control returns from max, we're popping these one at a time. Let's move on to the next frame, or the final frame. Now that we have system out printlined, notice that the entire call stack portion calling for num1, 2, and results are gone. Now that we're left with k, j, and I. And these values are used in the very last line of your main. The system out print line is complete. Your k, j, and I will be popped off of stack in that order. And then your stack is going to be empty again. This is how call stack works using this main console application invoking max function. There's a couple of other references included in this topic. You may reference those examples for more information to glean insight into how call stack works.